So yeah, this is running for an hour or something like that, and so these are the parameters right now. So 0.09, 0.1, 8.3, and 0.2002, and these are the values that I started with. So going from 4 to 8, 6, going from 6 down to 1. So yeah, it is working. So showing you here the curve. You see if I'm for testing 3 different speeds, and yeah, really looking good. And the slow speed really was a main problem, and therefore the logic is I calculate the errors for the different speeds that's here, and if then I only take the maximum, so you see it's the slow speed was the maximum, and if then there's a difference to the other for more than 30%, then only first optimize this speed. And then I go through all the 3 different PID parameters, and then I optimize. I do it. You see, this is now brand new. Doing here on the position 0, that's now here the KP, and the integer is a direction, a tenth of the value, and then one. You see now first I was at 0, and then I started at 1/10 of the value to the left, but that was not good, so I went back to 0. And this I do so long until in this array 3 times the same value. So you see, if I 3 times test the same configuration, then it's not worth. But in the beginning, you see here going up to 8, you see there are sometimes it's 1 plus 2 plus 3 plus 4 plus 5, and so they don't repeat. And so you see, if here in this this buffer of the last 10. Then I have 3 times the same settings, then I go to the next. So are we still here at the, no, you see now we are position 1. So now we are, you see, testing this. And right now we are testing all the 3, but as I said, if here the failure is 30% difference to the others, then I switch here to, you see, then it's no longer -1, but the speed that I want to test, and the count here is set to 3. So I weight all the 3 different PID parameters before I then go back to testing the other speeds. And okay, now I want to show you. I simply turn off this nice curve and turn it on again, and then maybe here the LEDs will come back. So let's turn it off, and so now all is lost. and turn it on again, and you see that's how I did start. You see at low speed, and this was a mid speed, and the high speeds, these are already okay, but you see, go back here to the table. Then you see here there we have 98% failure rate. And if this doesn't really help, I also increase the threshold. It's 2 things happening at the same time. So I try to optimize the PID parameters, but if I really am above 60% error, then I widen the threshold. That's so you see, I think here 83. That's don't find it right now. You see, I've added a new file. It's here something 100% error would be 1034, and at 5, so roughly a tenth. So going back here, so now I'm at 12% threshold. So you see, because if the threshold is, then I get 99%, so there's nothing I can optimize. So I need to widen the range. You see, so you see right now, this is at first really try and error, but also you see widening the threshold, and then yes, after some time, really it somehow by chance optimizes, finds a way that it's better, and then it, you see, after you see here now you've already passed the cycle of the 3 parameters. So the next time I think we go back to 1 full to re-evaluate the settings. I see. So let's wait. But here you see now here 65654. It really makes progress in the optimize ads. So here, yeah, that's, you see this 6. This was crucial, and now you see it did repeat 3 times, and now it re-evaluates this. And so you see this is now less than 30%, 21, and therefore it continues. But here again now it's found, you see 70, and so it's back to optimizing the slow speed. But you see it it seems to work. You have to let it run, and still need to test it then for position. Torque is a bit different. You see here it's for positions also. You see the failure rate is, you see, if you are within 5%, or this is the threshold, the target position. Torque is a bit different because you have to apply a torque, otherwise it cannot reach this torque. So yeah, here I want to show you here at with this STM Studio, only Windows, you can also import variables here, import, and then you can change this for this speed, for example. So so you don't really need to I think I will remove from test speed the Arduino this keyboard forwarding, and you can do that here. But I also plan to add here this remote optimized PID RGT target. So with platform IO or with standalone on Windows, you can make a telnet connection, and so you get can over the ST link also get some feedback for the non-Windows users who don't have this, cannot use. But you see, okay, for monitoring there is this STM MCU viewer, and so but the MCU viewer, I did not find a way how to change variables, but you do not really need that. You only, but I think with MCU viewer you also do not really see this where you can see the table of data, and right now you need them here finally to get the values that you want. Yeah, 4.8 and 0.1. That, I think, the values that I also found here of myself by hand. And yes, of course, you see by hand, if you know what you're doing and know the meaning of these parameters, you're way faster. But you see, I really did not want to go into this details and so, and all the other people, some still active on GitHub, but no one really started tuning, so I had to find my way. This might really be so you simply go here to config, and there is now, here's this define, and then you you see different motor. Perhaps you see I don't have here the rubber, which makes it more heavy, so the momentum is different, and therefore you see different motors might need different settings, and so you simply can optimize them. Now you see, and yeah, it's looking good by now. You see, that's the fastest speed, and yeah, the slow is also working. So yeah, my little optimizer. This is no AI. Just it's the steepest ascent that is also used for deep learning algorithm. But it's a no neural network, and I still wonder if will AI be so intelligent to really come up with such an optimizing algorithm, just from scratch. You see, not seeing thousands of optimizing algorithm in the internet and then simply do it alike. So you see, but just start from some vague ideas and then okay. So maybe I'm back when I have this RTTT, but this is already good enough. Bye bye.